LeetCode 1762. Buildings with an ocean view might sound serene, but it's a classic efficiency trap. Picture live streaming a city skyline. Only the tallest buildings with a clear path to the ocean on the right should stand out. Checking every building against all others to its right? Way too slow. Let's find a smarter, sharper way to surface those unobstructed views. Let's warm up with the brute force idea. Check each building against everyone to its right. Not elegant, not fast, but it gets us going. Let's drop it into code and see where it slows us down. First, we'll set up a list to collect the indices of buildings that pass the ocean view test. We'll walk through the buildings from left to right, evaluating each one in turn. Each time, we'll assume the current building has an ocean view until proven otherwise. To test that assumption, we scan every building to its right. If any are equal or taller, that blocks the view. If no taller building shows up, this one gets the green light. We add its index to the result list. Once we've checked them all, we convert our list into an array to match the expected output format. This brute force approach clocks in at big O of n squared, brutal for large inputs. With 10,000 buildings, that's 100 million comparisons. The space use is minimal, but the time cost, way too steep. Let's tighten things up. Instead of rechecking buildings we've already seen, we'll scan from right to left, keeping track of the tallest building so far. That lets us skip redundant work entirely. We start by creating a list for our results, plus a variable to track the tallest height as we scan from the end of the array. Since the ocean is on the right, we move backwards through the array, checking if each building stands taller than anything we've seen so far. If it does, we know it has a clear ocean view. We add its index to our result and update the max height we've seen. Because we're collecting indices in reverse, we need to flip the result list to get them in left to right order. And finally, we convert the list into an array to match the function's return type. This approach runs in big O of n, just one pass, no nested loops. Space is O of n for the result. This greedy right-to-left scan is efficient, interview-friendly, and perfect for large-scale systems. We began with brute force, straightforward but slow. It checked every pair and paid the price. The breakthrough? Reversing our scan and tracking the tallest seen so far. That eliminated wasted work and solved the problem in linear time. This right-to-left strategy isn't just smart, it's practical. It powers things like skyline rendering and stream analytics. Learning to flip perspective like this isn't just clever, it's what sets great engineers apart. Try applying this scan trick elsewhere. It's a skill that pays off across problems.